Welcome back. In this video, we're going to go over section 9.3, which is about adding and subtracting square roots. So the idea of adding and subtracting square roots depends on the idea of like roots or like radicals, which is really similar to the idea of combining like terms when you're just doing like terms. So let's take a look. Square roots that have the same radicand, that is the same stuff underneath the square root sign, are called like square roots or like radicals. So for example, 3 square roots of x and 2 square roots of x are like radicals because they both involve square roots of x. Square root of 15 and negative 7 square roots of 15 are like. 3 square roots of xy, negative 10 square roots of xy. So the stuff underneath the square root sign is the same, and that makes them like radicals. Some, or like square roots. Some not like square roots would be 3 square roots of 7x and 2 square roots of x. Although they both have an x, the one on the left has a 7, the one on the right does not. So that's sufficient to make them not like. 5 square roots of xy and 2 square roots of y, not like radicals or not like square roots. So this is going to play out similarly to how you combine like terms when you're earlier in algebra. When you combine 2x plus 3y plus 7x plus 4y, we can see that the 2x's and the 7x are like terms. So you'd say, well, that's 9x. And then 3y and 4y are both y terms. They're the same. So we'd say, okay, well, that's 7y. You identify the terms as being like based on their variables and what powers those variables are raised to. Similarly, for radical expressions, you take a look at the root and see what's underneath, and that helps you decide which radicals are like which radicals. Okay, so 8 square roots of 2 minus 9 square roots of 2. This is going to be negative 1 square root of 2. You can kind of think, if you were to thinking like, well, what would 8x minus 9x be? That's x, right? Here our x would be like the square root of 2. We're just combining up things. Here the thing is going to be a square root of x. 2 square roots of x plus 7 square roots of x makes 9 square roots of x. Let me write that a little better. 9 square roots of x. Okay, 7 square roots of a minus 6 square roots of b. Kind of a trick question. Sorry, there's nothing to combine here. It's not square root ab or anything of that sort. It's just that 7 square roots of a minus 6 square roots of b. Two radicals are not like there. You can't do anything. It's just done. Okay, let's try some more. 4 square roots of 11 plus 2 square roots of 11 plus 3 square roots of 11. Just as if you had 4 sticks of gum and 2 sticks of gum and 3 sticks of gum, how many sticks of gum is that altogether? Well, that's 9 sticks of gum, or square roots of 11 in this case. All right, let's try some square roots of 5s and square roots of 6s. 5 square roots of 5 minus 4 square roots of 5, that's 1 square root of 5, plus 2 square roots of 6. And that's as good as it gets. I can't combine that any further because one is square roots of 5, the other is square roots of 6. And so we can't combine it any further than we already have. Okay, let's try some more. A couple of more. Square root 7x minus 7 square root 7x plus 4 square root 7x. So let's see, we've got 1 of something minus 7 of that same something. That's negative 6. Negative 6 plus 4, that's negative 2 of that something. That something is the square root of 7x. Okay, here's one for you to try. Take a minute, pause the video, try this one yourself, then restart the video and see how you did. All right, so this time our radicand is 5xy. I have 1 of them plus 5 of them. That's 5 of that square root minus 7 of that same square root. So that's 5 minus 7, negative 2 square roots of 5xy. Okay, and that's it. Most often, it's not that easy. Sorry, hopefully you found it easy. Usually you need to simplify first. Like when you see the square root of 18 plus 6 square roots of 2, at first glance you might say, okay, well, those are not like radicals, and so we're all done. But the square root of 18 can be simplified, and if you think about it, it's going to be 9 times 2, and there's that 2. So if we simplify that square root of 18 first, then we should be able to combine things. So let's try simplifying that square root of 18 first. 18 is 9 times 2. Using our product property of square roots, that's the square root of 9 times the square root of 2, or 3 square roots of 2. So that square root of 18 is really 3 root 2, plus the 6 root 2 we had in the back. 3 plus 6, that's 9 of those square roots of 2. So realistically, when you're doing problems like this, you're not going to have like this ones where they're already like so much. Most often you need to simplify first, as we did here. Let's try another. Here, the square root of 32, square root of 18. The more practice with this you get, the more you're going to kind of recognize these things. 32 is 16 times 2, 18 is 9 times 2. So again, we've kind of got that 2's going on again. So 32 is 16 times 2, 18 is 9 times 2. Product property of radicals again. This will be the square root of 16, square root of 2, minus square root of 9, square root of 2. The square root of 16 is 4. Square root of 9 is 3. 4 square roots of 2 minus 3 square roots of 2 is just 1 square root of 2. That's nice. It's always very satisfying to get it down to something so little like that. Okay, here's one for you to try. We have 4 square roots of 27 minus 3 square roots of 12. Take a minute, pause the video, try this one yourself, restart the video, and see how you did. Okay, 27 is 9 times 3, and then 12 is 4 times 3. So we're going to use that product property of radicals. This will be 4 root 9 root 3 minus 3 root 4 root 3. 4, the square root of 9 is 3. And then 3 times 4 root 4 is 2. Okay, 4 times 3, 12. We have 12 square roots of 3 minus 6 square roots of 3. That will leave us 12 minus 6 is 6 square roots of 3 in the end. Okay, let's try this again. This one has got some fractions in it, but you'll be all right. Okay, 2/3, 108. 108 is divisible by 9 at least. So let's go ahead and divide through by 9. 9, that's going to give us 12, right? So 108 is 9 times 12. So 12 as another perfect square as a factor. So we'll do it step by step, though. That's okay. So this will be 9 times 12. And then in the back, we have 5/7. 147, that's 49 times 3. So we've got, again, 2/3, square root of 9, square root of 12, minus 5/7, the square root of 49, square root of, okay, 2/3. Square root of 9 is 3. Square root of 12, I can do something more with that. We'll do it in a minute. 5/7. The square root of 49 is 7. Okay, 2/3 times 3 is 2. The square root of 12, we're going to simplify that. That will be 4 times 3. Our 5/7 times 7 is 5, and then that's still multiplied by that root 3. And so here, the square root of 4 is 2. So we have 2 times the square root of 4, which is 2. That gives us 4. We'll have 4 root 3 minus 5 root 3. This took a little longer because I did that square root of 108 in 2 steps, but that's okay. So 4 root 3 minus 5 root 3 is negative square root 3. Okay. Usually when you're simplifying radicals, it's best to take big a bite out of it as you can. But if you need to break it down in multiple steps like I did here, then that's okay. You can still get to the correct answer, just as we have done. All right, here's one more for you to try. We have 2/5 times the square root of 32 minus 1/3 times the square root of 8. So with this one, pause the video, try it yourself, restart the video, and see how you did. Okay, so 32 will be 16 times 2. And then 8 is 4 times 2. We'll have the square root of 16. Square root of 16, square root of 2 minus 1/3, square root of 4, square root of 2. Okay, the square root of 16. Sorry about that. Zoom crashed once again. So 2/5, square root of 16, square root of 2. The square root of 16 is 4. 4 times 2 will give us 8. So we'll have 8/5 square root 2. And then the square root of 4 is 2. So we will have 2/3 square root 2. Okay, and so this one, we're just going to, for a second, we're just going to have to do a little fraction subtraction, but that's okay. Let me factor out that square root of 2. So we'll have 8/5 minus 2/3. That's going to be 15ths. So that's 24/15ths. And then 10/15ths. And then it's multiplied by the square root of 2. And so then now we're subtracting 15ths. 24/15ths minus 10/15ths is going to be 14/15ths. So we'll have 14/15ths times the square root of 2. Okay, here's another to try. We have the square root of 32 a to the 7th minus 50 square roots of a to the 7th. So for this one, there's a couple ways to approach it. We could simplify that square roots of a to the 7th now, or we could do it later. My choice would be to just do it later and deal with the 32 and the 50 first. So we'll have 32 is 16 times 2. And then 50 will be 25 times 2. Okay, now product property of radicals. This will be the square root of 16 times the square root of 2a to the 7th. And then we'll have the square root of 25, square root 2a to the 7th. Okay, and then the square root of 16 is a 4. The square root of 2a to the 7th still here. The square root of 25 is a 5. Then again, the square root of 2a to the 7th is still there. 4 minus 5 is negative 1. So we'll have negative square root 2a to the 7th. So now at this point, I'm going to simplify the part involving the a's. Again, we could have done this earlier, but my choice was just to save it until right now. So we have negative and then the square root a to the 6th times 2a. I've separated those 7 factors of a into the perfect square part and then the part that is not a perfect square. So this will be negative, and then we'll have the square root of a to the 6th, square root of 2a, using that product property of radicals again. Okay, the square root of a to the 6th is going to be a cubed. And so we'll have negative a cubed square root 2a. Okay, so that was a fair amount of steps, but we did it. Okay, here's one more to try. This one's 7 times square root of 48y squared minus 4 square roots of 72 y squared. So 48 is 16 times 3. 72 is 36 times 2. So let's take care of those perfect squares, and also we have those square roots of y squared that we can deal with. So where on the previous example, I saved the simplification of the variable to the end, I'm going to do it now on this one just for variety's sake. Okay, so here for the first part, we have 7 square roots. Then we'll have 16y squared times 3. I've separated the perfect square part, which is the 16y squared, from the 3, which is not a perfect square. And then in the back, 72 is 36 times 2. So I'll have 36y squared times the minus times 2. All right, and so now we've got 7. The square root of 16y squared and square root 3 minus 4 square roots of 36y squared square root of 2. Okay, 7, the square root of 16 is 4, so we'll have 7 times 4y square root 3 minus 4, the square root of 36y squared will be 6y. And then this will give us 28y square root 3 minus 24y square root 2. And then on this one, the square root of 3 and the square root of 2 are not like radicals. And so that's kind of as good as we can get with it. If you want, we could factor out a 4 and a y, but that's kind of not, it's not essential. So that's as good as that will get. It's kind of unsatisfying. It would have been nice if they were both square roots of 3 or square roots of 2, but it was not to be. All right, moving on. We have just one left, and then we're all finished. So with this one, we have the square root of 12x squared, a square root of 48, and a square root of 27x squared. So I can see that middle radical doesn't have an x in it. We'll see what happens. Okay. For the 12x squared in the first term, I'll separate 4x squared from the 3. And then in the middle term, that 48, once again, is going to be 16 times 3. And then in the back part, 27x squared will make that 9x squared times 3. So I can see there's that extra factor of 3 in all of those radicands, so that's kind of nice. So we have 3, the square root of 4x squared, square root 3, minus 2x, the square root of 16, square root 3, plus 4, square root of 9x squared, square root 3. Okay, 2 more steps and we're all done, I think. The square root of 4x squared will be 2x. So in the first term, we'll have 3 times 2x times the square root of 3. In the second term, the square root of 16 gives us a 4. So we'll have 2x times 4 times square root 3. In the last term, we have 4 times 3x square root 3. I lied, maybe 2 more steps now. 6x square root 3 minus 8x square root 3 plus 12x square root 3. So here we're combining variable terms, and also each has a factor of square root 3. So we have 6 minus 8 is negative 2. Negative 2 plus 12 will be 10. So we'll have 10x square root 3. Or if you want 10 to write 10 root 3x, that's also okay. If you do write it that way, make sure that you end that square root sign before the x. That's not the same as 10 square roots of 3x. So make sure that your x doesn't kind of accidentally sneak underneath the square root sign. Only the 3 is underneath the square root sign here. All right, that takes us to the end of section 9.3. Let me know if you have any questions, and have a great day.